Welcome to Chapter 13, Part 3, for the binomial distribution. We're going to begin this Part 3 with talking about the mean and standard deviation of a binomial distribution. It's a very easy calculation, and it will be the only standard deviation you'll be required to calculate for quizzes and tests. So let's look at the mean of a binomial distribution. Again, you know that the mean is represented by mu and equals n times p, the number of trials times the probability of a success. Sigma, the standard deviation, is equal to the square root of the product of the n times p times 1 minus p. And that's how we calculate the mean and standard deviation. So let's look at the switch problem. Remember that our random variable was the number of bad switches in our out of the 10 switches we were looking at. So n was 10 and p was 0.1. To find the mean and standard deviation, we're going to say 10 times 0.1. That gives us, we have a mean of 1. So the probability of each being bad is 1/10. So we expect on average to get one bad one out of 10. Now to calculate the standard deviation, we would say 10 times 0.1 times 0.9, because 0.9 is 1 minus 0.1. And when we do that, we get the square root of 0.9, which is 0.9487. So for this distribution, we have a mean of 1 and a standard deviation of 0.9487. So this is what the probability histogram looks like for 10 switches with a probability of 0.1 for having a bad switch. We see our mean, and we can see how this distribution tapers off very much to the right, so it's a very right-skewed distribution. Now let's look at the cumulative distribution function for this for the 10 switches. Now look at where it ends. It ends at 7. Now remember, there are 10 switches. It very much goes in line with the distribution we just saw. There's no contribution to probability after 8. So we don't see any probability for 8, 9, or 10 switches. The probability of having 8, 9, or 10 switches is so small, it's negligible in our contribution to our CDF. In other words, the probability of having 9 bad switches is very, 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 very small. And that goes along with what the distribution looked like. Look at it. When you look at even above 5, 6, and 7, you can't even see the bars. They're so small. So just for something to think of. So let's look at this example that's found in your Minitab examples. It says the following example will show how to use Minitab to solve a binomial problem. It says a national poll conducted by the New York Times several years ago revealed that 80% of Americans believe that after you die, some part of you lives on, either in the next life on earth or in heaven. Now consider a random sample of 10 Americans and answer the following questions. Now, this is a binomial because each person would be independent of one another. There are 10 people we're looking at, so we have a fixed number of trials. The probability of a success, either you believe or don't believe. So there's only 2 outcomes, and the probability of it believing is 0.8. So this is definitely a binomial. The 4 conditions are met. So I'm going to do the CDF in Minitab, and this is the cumulative distribution function I get. So let's see how we would answer some questions. Well, first of all, let's look, what's the probability of observing 3 Americans who believe in life after death in a sample of 10? So that's an exact binomial, the probability that x equals 3. The way we would solve this is we'd say the probability that x is less than or equal to 3, and subtract off from that the probability that x is less than or equal to 2. So we'll be left just with exactly 3. What is the probability of observing at most 7 Americans believing in life after death in a sample of 10? At most 7 means 7 or less. So when we look at that, we see the probability that x is less than or equal to 7. That's exactly what a cumulative distribution function is about. So we would pick that number right off the distribution. So let's look at another question. What is the probability of observing more than 4 Americans believing in life after death in this sample of 10? Now that's more than 4, meaning I'm not going to include 4. I want more than 4, which would mean 5, 6, 7, 8, 9, and 10. So if I want probability that x is more than 4, that's the same thing as the probability that x is greater than or equal to 5. That would be another way to look at this problem. Or I could say I don't want to include 4, so I would take the whole probability distribution and subtract off of that everything 4 or smaller. That would give me more than 4. So you use the complement rule here. So let's look at the next problem. What is the probability of observing 6 or more Americans believing in life after death? In other words, our distribution has to include 6. So I want 6, 7, 8, 9, and 10. So I'm going to take the whole distribution and subtract off of that 5, 4, 3, 2, and 1 to get my answer. And here's the last problem. What's the probability of observing between 4 and 6 Americans believing in life after death out of the 10 in our sample? Well, that's an in-between. So we went between 4 and 6. That means I want to include 4 and 6. So I'm going to have 4, 5, and 6. How would I find that? Well, if I did the probability of everything less than 6, I've got too much probability. I've got 3, 2, 1, and 0 in there that I don't want. So I need to subtract that off. So the way I do that is I say the probability that x is less than or equal to 6 minus the probability that x is less than or equal to 3 to get my answers. Now, that's how we do by hand by doing this. If I wanted to do the same things in Minitab, there would be the certain commands that we would use. So this first one, the first Minitab command that we're looking at is the probability that x is exactly 3. So we'd have to take the 3 or less and subtract from that 2 or less. And this is the command that we would do it. Because remember, in Minitab, we do our command, we say the number, the x value, and then the probability we need to hold it in some constant. And in this case, I'm going to call it K2. Now for my CDF of 2 or less, I'm going to hold that probability in K1. So at the end, I need to find the probability of exactly 3 would be to take my distribution of 3 or less and subtract it from 2 or less. So I take K2 minus K1, my probabilities, and I'd have my answer. For the probability of 7 or less, having no more than 7, then this is the command I would use. I just do CDF of 7, binomial 10.8. For the problem, the probability of more than 4, that was number 3. This is the CDF command that would go with that. And then 6 or more would be number 4. That's how we would do that one. And when we have the in between, that's what we see here in number 5. So now you should be able to do all your homework in Chapter 13 in the post-test. And now Quiz 5 will be opened up because Quiz 5 deals with Chapter 11 and Chapter 13. Please make sure that you go on to Minitab examples on Blackboard so that you can see the commands that go with binomial, and for each different case, less than, greater than, in between, that you see how to use the commands in Minitab. Also on the example that I just did. So this concludes Chapter 13.